Let's look at an SSD treatment planning system example where we're calculating parallel opposed fields to a calculation point that is midline, midplane in the patient. It's not going to be isocenter because the isocenters technically are at the patient's exterior skin surface since we're setting a 100 centimeter SSD. So you can see my calculated SSD here is 100. I've already calculated the dose. I have a calculation point that's midline between the anterior and the posterior, and then midplane, left to right. It's on the central axis, and there's no wedges. So I have a 6x field, APPA with a 10 by 10 field size. If I turn the dose on, we get this classic hourglass shape that we talked about with APPA or parallel opposed treatments. Again, if I take a look at the dose profile going from anterior to posterior, we get two very nice percent depth dose curves, one from the anterior here, which peaks right about 1.5, and then one from the posterior as well, which is going to go 1.5 and then fall off region. And the combination of the two of them is going to give us this blue, which gives us this little dip in the center in one dimension. If we look in two dimensions, it gives us this classic hourglass shape that we talked about earlier as well. 95% is the cyan color that essentially covers the entire column from anterior to posterior. If I were to look at a beam's eye view of this particular field, this is what it looks like. My calc point right on the central axis. Okay. Let's go to calculating the monitor units for a secondary dose calculation. You can see that I've got my dose per fraction is 200. I'm normalized to the calc point, and I have a 50-50 beam weighting in this plan. My monitor units are about 151 MU. Now, I want to calculate dose. And for this, let me delete all of this. And I'm going to assume that the AP and the PA, they're going to be identical. And I think the planning system shows us that, so I'm only going to calculate monitor units for the anterior field. So my monitor units for the anterior field are going to be the prescription dose times the relative beam weighting for that field, 50%, divided by collimator scatter factor, phantom scatter factor, my percent depth dose, and then my isodose line. In this case, my isodose line is 100%, so that factor drops out. So we go mu AP is going to be 100 centigrade divided by S sub C is 1.0. S sub P is 1.0 if you look at the data tables. And then my percent depth dose, if I look at a 10 centimeter equivalent square, and we need to get the depth. If I go to my report, okay, my SSD is 100 and my depth is roughly 10. Again, we're not going to look at equivalent path length because this is a homogeneous calculation. Field 2 you can see is effectively the same. My fractional dose is 100, my SSD is 100, and my depth is 10. So if I look at my data book, and my table says that for a 10 centimeter equivalent square at 10 centimeters deep, my percent depth dose is 66.4%. My isodose line is 100%. So my MU from the AP is going to be 100 divided by 0.664 gives me 150.6. The treatment planning system said 151.4. So if I look at a percent difference, I'm looking at 150.6 divided by 151.4 is 0.5%. Let's take the same example for APPA, and then let's do a normalization. So I'm going to normalize, instead of normalizing at the calc point 200 centigrade, which is what I have right now, I'm 100% of the dose at the calc point. I want to normalize and make 200 centigrade delivered to the 95% isodose line. So my prescribed percentage I'm going to change to 95%. I'm going to change my isodose lines to reflect that. You can see how the red moves out to where the 95% isodose line used to be. I'll turn absolute dose off. 95% now is still in the same orientation that it was previously. However, it now represents the 200 centigrade line. So if I move my dose cursor to the calc point, and I look at the calc point, 210.5 centigrade is being delivered to the calc point. And if I move my little dose cursor out to the 95% isodose line, you can see that roughly 200 centigrade is being delivered to the isodose line. This makes sense. Look at my monitor units for the machine. They've gone from 151 to 159. So I'm leaving the machine on for a longer period of time, means that I'm pumping more dose into the patient. More dose is going to my calc point, thus more dose is going to the previously described 95% isodose line. So how does this work with the monitor unit calculations? So my MU from the AP still stays the same. I have 200 centigrade times my relative beam weight is 50%. S sub C, S sub P don't change. My percent depth dose doesn't change. However, in this case, my prescribed isodose line changes to 0.95. So if I take 100 divided by 0.664 divided by 0.95, I get 158.5. My treatment planning system MU were 159.3. That's how normalization affects the monitor unit calculation.